MC delta T gives us 0.904 kilojoules of heat. And if I summed all of those values to move from point A, B, C, point D, point E, point F, from move to point A all the way to point F, it's the sum of each one of those separate line segments, one at a time, added together. If I took 1 mole of water as solid ice at -25, and I ended with gaseous steam at positive 125, it took me 1, 2, 3, 4, 5 separate algebraic problems added together to find the total kilojoules of heat. In a practice, instead of using water, it wants us to do the following. How much heat in kilojoules is needed to raise the temperature of 12 grams of benzene from -10 to +25? The best thing I can do is figuring out how many line segments and what's going on. I'm going to get a clean piece of paper. I have to generate a little graph to figure out how much information, how many line segments do I have? All right, so here's the heat, here's the temperature. If we're starting at -10, and we're going to +25 degrees. -10 will be point A, 25, I'm not sure how many line segments is going on from there. Here's the data. Specific heat of a solid. So that's an MC delta T when I'm in the solid phase. The C constant I will use is 1.25 joules per gram Celsius. Specific heat of a liquid. So if I'm in the liquid phase, it's an MC delta T problem for the liquid. The C constant here is 1.7. If I'm in the gaseous phase, the MC delta T for the gas, that C constant will be 1.24. Alrighty. Other things to note, at 5.5, I'm going to see a phase change. That's the definition of a melting point. The melting point means I'm going to turn from solid to a liquid at 5.5 degrees Celsius. Another good thing to know is a boiling point. That's a phase change. From here, I have a liquid turning into a gas. The delta H of vaporization, 30.9 kJs per mole. Heat of fusion, by the way, that's a phase change value going from liquid to gas. This is the temperature at which it occurs. I was just trying to clarify. This is the temperature, the the y-axis, and delta H then is the line segment that phase change will occur. Heat of fusion is when a solid turns to a liquid, and the molar mass of benzene, C6H6 is its chemical formula, 78.11 gram per mole. So all of this information is provided. I have a hunch we're not going to use it all because we're not nearly going up as high as 80 degrees. So we'll never turn the liquid to a gas. We're only using part of the line segment. If we start at -10 and move to 25, let's decide what phases of matter we are indeed in. So if I start my line segment at point A, -10, the first point of interest is at 5.5 degrees Celsius. At 5.5 degrees Celsius, we're going to see a phase change. So therefore, from point A to point B, I must be in the solid phase of benzene. Because if it's melting, I must have started solid and now it's going to melt. The process of changing phase is a flat line. The process of changing phase is a flat line defined as the delta H of fusion. So line segment AB I know is an MC delta T where the specific heat constant here is in the solid phase. This, by definition, is the heat of fusion, how much energy it takes to turn the solid into a liquid. Then I continue to add energy, but it says end at 25 degrees. So I have one more line segment, but it's going to terminate at point D, just warming up the liquid phase up to 25. I don't have any more phase changes because the next phase change occurs at 80 degrees, and I'm well under that, stopping at 25. So it looks like our problem has 1, 2, 3 separate line segments. Finding the total heat will just be the sum of those 3 parts. So I'm going to continue. I'm just going to put this slide to the side because it has my values, but I'll do my algebra here on this separate sheet of paper. We have a line segment AB, we have a line segment BC, and a line segment CD. Since we're changing temperature, Q is an MC delta T problem. So M times C times delta T. The mass they gave us is 12 grams. So there's the M for the MC delta T. 12 grams of benzene. The specific heat of a solid, 1.25 joules per gram Celsius. And the temperature change, well, I started at -10, and I went up to positive 5.5. So the temperature changed by 15.5 degrees. So here's my MC delta T. This will land in a joule, and I'm going to divide by 1,000 while I have my calculator going, because I know I have to end it with a kilojoule to add like values. Question asked me how much heat in kJs. So while I'm hitting, I'll just report this answer in a kilojoule. So I'll hit 12 grams times our specific heat of solid benzene, 1.25, times our delta T of 15.5, divide by 1,000 to turn the joule into a kilojoule, and I get, and I'm going to write this in black so we can see it clear, 0.2325 kilojoules of heat from line segment AB. Line segment BC is a phase change, and we're melting, so that definition is a heat of fusion. It says it takes 9.8 kJs for every mole of benzene to melt. So, if we have, and we do, the number given was 12 grams of benzene, we have to use the molar mass of benzene to get it into a mole, and that was given to us. We could add up C6H6, but look at the last line. They gave us 78.11 as the molar mass. 78.11 grams is our molar mass. So grams divided by molar mass gets us the mole. And now for the heat of fusion, 9.8 kJs per mole. And now all the units have canceled, and I've ended at a kilojoule. Since I put a kJ in, a kJ comes out. Up here, this was a joule unit, so I had to slide my decimal to fix it into a kilojoule. So let's solve for line segment BC. 12 grams divided by the molar mass of 78.11 times 9.8, the heat of fusion,